Welspun Corp Limited is a global leader in manufacturing steel line pipes for oil and gas transmission across multiple terrains. Some of the most prestigious gas pipelines around the world are made of Welspun carbon steel helical submerged arc welded line pipes. This includes the longest cross-country pipeline of Keystone, extending from Canada to the United States. Welspun Corp Limited is the flagship company of the Welspun Group, an Indian conglomerate with a growing global presence in home textiles, infrastructure, steel and line pipes. Welspun Corp has its steel pipe manufacturing facilities located in the USA, Saudi Arabia and at 4 strategic locations across India. Welspun City in Anjar in coastal Gujarat is one of the largest steel pipe manufacturing complexes in the world. The complex has 13 different manufacturing units, each one dedicated to the specific type and size of pipes. This facility has capabilities to manufacture pipes from 610mm to 3048mm in diameter, with thicknesses varying from 6mm to 27mm, all conforming to API and other international standards. Long-lasting pipes are born out of high-quality steel coils sourced from reputed companies globally. Samples from every consignment are tested at the Quality Control Laboratory to verify the properties of the steel. Visual inspection is also carried out on the coils to ascertain the quality marking and to ensure that the coil is free from any deformities. Welspun has installed a series of automated material handling systems with large-scale automation of the production process to eliminate human error and also to ensure continuous production with consistent and precise quality. The coils are loaded onto a non-stop coil feeding line. The decoiler ensures proper centering and alignment while decoiling. The first stage pinch roll pulls the strip from the decoiler and feeds it to the leveler. The online coil end cross milling and parting system automatically cuts and mills the edges of both the parting coil and the new coil at a bevel angle of 45 degrees to ensure proper and consistent welding. The coil-to-coil welding takes place on the flying cross-seam welder, equipped with the latest automatic SAW welding system with 2-wire tandem welding. The next stage is the online ultrasonic testing of coils with ultra sensitivity using the latest electronics and probes. The system has a true position paint marking with an audio-visual alarm to notify any flaw or decoupling information. After ultrasonic testing, the coil undergoes edge milling on the Linsinger system with heavy-duty drives and high-precision cutting tools to obtain a perfect bevel geometry on the top and bottom of the strip to facilitate perfect welding. The second stage pinch roll leveler feeds the strip into the continuous pipe forming mill while strictly controlling the levels and tolerances. The helical pipe forming mill draws the coil at a consistently steady speed for precise helical formation. An automatic GMAW track welding system provides high-speed welding with spatter-free finish. As the pipe is formed and welded, a moving automatic plasma cutting machine cuts the pipe precisely to the desired length. An automatic handling system then transfers the pipe to the final welding bay. Each pipe undergoes a thorough cleaning of the ID surface on the Pipe ID cleaning machine to remove any dust, foreign particles and weld spatters. An OD cross-seam plate is welded on the top side of the pipe to maintain strict tolerances during final welding. A row of welding stations carry out final ID welding through the SAW process. Next, the pipes move towards the final OD welding lines, where a perfect welding finish is achieved on the outer diameter of the pipe. The ID and OD welding systems have a digitally controlled inverter power source capable of providing both AC and DC power. The system provides a visual display during welding and facilitates laser tracking of the weld groove and stick-out control. The welded pipes arrive at the pre-visual inspection section. Here, the quality inspectors conduct weld and body inspection of each pipe with regard to the weld quality on both the ID and the OD. If any surface defect is observed, the same will be rectified prior to radiography. Real-time radiography is carried out on a GE inspection technology system, covering the full weld length at a test speed of up to 6 meters per minute. As a quality management practice, an intermediate ultrasonic testing is carried out with 100% scanning of the weld seam. The system has an automatic spray marking and provides a graphical report on each pipe. Next in line is the hydro tester, equipped with high-pressure pumps and water circulation systems. The system has safety interlocks and displays recordings of pressure and holding time with a graphical printout. The next stage is automatic seam ultrasonic testing with 100% scanning of weld seam with high sensitivity for measuring and detection of any weld imperfection. Laser sensor-controlled automatic seam tracking, along with an automatic vertical lifting unit and a transverse shifting device, ensure correct positioning of the probe assembly on the weld seam. The pipes are then passed through the manual ultrasonic testing station for checking the untested portion of pipe ends and the spray portion of the automatic ultrasonic testing machine to detect any defect in welding. The pipes then undergo a seam X-ray at the state-of-the-art X-ray unit. Further, a magnetic parcel inspection is carried out to check any laminar defect at the bevel ends of the pipe. Next is the end beveling machine, equipped with PLC-controlled feeding and drive system, offering high-speed cutting with a smooth finish. At the final visual inspection, the OD and ID of the pipe body and ends are verified. Thickness of body and the ends, ovality, straightness, length, peaking and the end squareness are determined. All the production parameters such as heat number, weld details, etc. are entered in the ERP system. The final cleared pipes are marked with ASL numbers and barcoding for future traceability. The next stage is pipe coating. The pipe coating plant incorporates multiple processes with fully automatic handling of pipes. The process begins with preheating, automatic shot blasting, surface cleaning and inspection of the blast surface. After this, the pipes pass through a series of online heaters to the coating section. The external coating involves a 3-layer polyethylene coating. First, with an anti-corrosive epoxy coating, followed by grafted adhesive coating, and finally, with an outer layer of high-density polyethylene. Internal coating involves shot blasting in a closed system, cleaning, preheating, and surface coating. The coated pipes are tested for uniform surface finish. The quality-approved pipes are marked with robotic stenciling. Finally, the main custodian of quality assurance is Welspun's Central Quality Control Laboratory. An array of the latest equipment and systems conduct multiple tests to ensure chemical and physical properties, mechanical strength, weld stability, and corrosion resistance. At Welspun Corp Limited, engineering excellence is a way of life, embracing the latest technologies and constantly adopting the world's best practices. Welspun is constantly developing newer solutions for manufacturing line pipes to meet the changing needs of customers around the world.